Hi, hello. My name is Hera Sudananantadong. My metric number is CF210091. So today, I'm gonna introduce you to our group member. Our first group member is Jovita Tan Royal, Nor Atikah binti Yaakob. The third one is Siti Nor Shazwani binti Sharul Nizat. And the fourth one is me. And the last one is Nur Amani binti Muhammad Nur. So today we're gonna explain about the application of differentiation and integration.
Hi, Assalamualaikum. My name is Nur Amani binti Muhammad Nur. My metric number is CF210310. So in this project, we have used two methods, which is differentiation and integration. In calculus, which analyzes change, integration and differentiation are two basic concepts. Calculus is used in a wide range of fields, including science, economic, finance, engineering, and so on.
Hi, hello. So today I'm gonna talk about problem statement for our project. So first problem that we're facing is that Company Y built a new apartment in front of BH Petrol. Thus, a congestion occurred from Batu Pahat to Kluang. Therefore, multiple differentiation and integration to the traffic data given is conducted. As a result, the interval rate of change, maximum and minimum number of vehicles are determined to solve the congestion issue before implementing high-rise building. Because in this case, they wanted to build a new apartment near the BH Petrol, which is lead to Batu Kawah to Kluang Jalan. So that's for problem 1. For problem number 2, which is the case is about by the end of 2021, Johor Bahru government decided to build a high-rise building near city center. The concrete used for building must meet a specific requirement by the Malaysian standard. Therefore, a set of analysis is assessed to study the flexure, strength and deflection or the concrete using various calculation methods. Once the values are obtained, the concrete grade can be chosen. So that's for problem number 2. They are trying to build a high-rise building. In order for do that, they have to study the flexure, strength and deflection. Thank you.
I'm Jovita Tan and my matrix number is AF210088. So I will talk about the solution of problem 1. In solution 1, we plot the graph and find the increase-decrease interval, rate of change, maximum and minimum number to solve the problem. So this is the graph of volume versus time generated using decimal, and the equation is also given. To find the interval increasing, decreasing or constant, first we generate the given equation. When increasing, f prime is larger than 0, and after calculate using computing the square, we can get x smaller than 78.2056 and larger than negative 12.8722. Since we set the range of equation is between 15 and 120, therefore it is increasing when x is larger or equals to 15 and smaller than 78.2056. For decreasing, f prime is smaller than 0. It decreasing when x is larger than 78.2056 and smaller or equal to 120. For stationary point, f prime is equals to 0. Therefore, it is constant when x is equals to 78.2056. Next, we calculate the rate of change of each 15-minute interval. By using this formula, we can get the rate of change of each 15-minute interval which listed in table 4. To find the relative maximum and minimum number, first we need to find the stationary point. From the concavity table show that the stationary point is a relative maximum point. Therefore, the relative maximum number is 341.8137 and no relative minimum number. Next, we compare the value when x is equals to 15, 120 and the relative maximum point to get the absolute maximum and minimum point. Therefore, the absolute maximum number is 341.8137 and absolute minimum number is 260.7862. This is the graph of average speed versus time generated using decimal and the equation is given. Then we differentiate the given equation to get the f prime x. Same as the graph of volume versus time, increasing when x prime is larger than 0, and because of the range we given, the interval increasing is x larger than 81.0917 and smaller or equals to 120, and decreasing when x prime is smaller than 0, the interval decreasing is x larger or equals to 15 and smaller than 81.0917. For stationary point, f prime is equals to 0, therefore it is constant when x is equals to 81.0917. Next, we calculate the rate of change of each 15-minute interval, same using the formula of rate of change, and the result is shown in table 9. From the concavity table show that the stationary point is a relative minimum point. Therefore, the relative minimum number is 68.2658 and no relative maximum number. Next, we compare the value when x is equals to 50, 120 and the relative minimum point to get the absolute maximum and minimum point. Therefore, the absolute maximum number is 75.3471 and absolute minimum number is 68.2658. This is the graph of cumulative volume versus time. Using the formula of rate of change, we can get the result shown in table 14. To calculate the average rate of change of the graph, the sum of rate of change of each 15-minute interval is divided to the number of interval, and we can get the value of 20.733. That's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nursyazwana binti Syahrinizat. I will explain about solution 2. To find the energy, we can use two methods. The first method is trapezium rule, and the second method is integration approximation function. This is the graph of flexural strength vs deflection. From the question of problem 2, we want to find the energy of the building. That's why we need to plot the graph flexural strength vs deflection. It is because the area under the graph is equal to the energy. The first method, we use the trapezium rule. From the graph, we can divide into 5 parts. We need to find the area of each part and add all the area to find the total area of the graph. From this calculation, we get the area under the graph is 1.4802 units square. We can conclude that the energy of the concrete is equal to the area under the graph. So, the energy of the concrete is 1.4802 Newton meter. For the second method, we use integration approximation function. From the graph, we know that the equation of the graph is y equal to 1.2416 times 10 to the power of 12 x cubed plus 2.5794 times 10 to the power of 9 x squared plus 667,222 x plus 145.834. To find the area under the graph, we use the limit from 0 to 0.000956. From this calculation, we get the area under the graph is 1.4548 units square. We can conclude that the energy of the concrete is equal to the area under the graph. So, the energy of the concrete is 1.4548 Newton meter. That's all. Thank you.
I will explain about the conclusion. Okay, we have found the solution for equation using and based on Desmos. Each of the strategies bring a basic and clear way along. These lines can be utilized for particles data. We have learned to solve the graph problem based on the equation. Based on our group meeting and discussion, we have solved both problem 1 and 2. Based on the graph, cumulative volume versus time show the sum of rate of change is 145.133 and number of interval is 7. After calculating average rates of change of graph, therefore average rates of graph cumulative volume versus time is 20.733. In problem 2, using the first method, which is trapezium rule, the value of energy that was obtained is 1.4802 nm. While using the second method, the calculating was used by drawing the straight line of the graph and the value of energy that was obtained in 1.4548 nm. The curve is concave upwards. Therefore, using trapezium rule, we'll have the overestimate from the trapezium rule will slightly more than the value given by the integration. As we can see that the difference between the two value of energy of the concrete are just 0.0254 nm. As the result, the total area for both methods are accurate.